Hello, we got two topics to cover on the OpenGL before we jump to porting game to the PSP. Mr. Who's the Boss just released a video on I bought every PlayStation available or something like that, and it drove a lot of traffic to my how to develop on PSP video. So for you guys to know what I'm really doing here is I'm teaching you OpenGL because I'm going to use OpenGL to port the Snake game to the PSP. So if you want to see that and if you want to code, then follow along with OpenGL. But today we're going to talk about matrices, and we're going to talk about matrix modes. Yep, so let's get into it and forget everything about old handhelds. So we start up our program, and I will start from this cube, and that cube, there's a video if you want to create this cube. First we're going to do is resize this screen. We're going to specify width and height. And we're going to put them up here instead. We need them later. So let's say 600. Yeah, that seems fine. Next step is to get rid of all of these things that draw the cube. I mean, we need to draw the cube, but not like this. So we create a draw cube. Maybe I should call it draw object. So it's unspecified what it is, but we know it's a cube. Get out that. And my last video was about vertexes and indexes and draw elements. And we're not using that today. We're going to use this cube instead of the other cube. And there's a good reason for that. This version has different colors on each face, on each side, and we will need that today because we're going to rotate it and show it from different angles. What we're going to do, you have seen the thumbnail on the video, I have not. So we're going to do something that kind of looks like this, but the cube in the middle instead. And this is called a multiview. It was very common back in the day in CAD software. So you have a coordinate system that's from above. I just draw a box around what I'm talking about. So you can see it from above. I see it from the front. And you see it from the side. And then you have a 3D view of it also. And if you look at these, this is from Blender, but if you, the old CAD systems work the same. If we look at these 4 different views, it's called a multiview. That's only one of them are really 3D. And that's this one. The others are of course also 3D, but they are orthographical. Hard to say that one. They do not have a field of view. Meaning, let's see which one we should take. Oh, that's hard to explain. Well, the field of view in games, you know, that's if you have an angle here, FOV, that's how wide you are looking. I knocked my mic there, but how wide you are looking. And if you look at these 2 other views or 3 other views, you don't have a field of view. You're just looking directly straight at it. You're not looking at an angle, you're looking straight at it. So we're going to create something like this today. Now on OpenGL. And we're doing that not because we need a multiview, we're doing that because we need to talk about matrices. So the first we need to do is divide this in 4 parts. So we will do a GL begin here lines. I'm going to draw a few lines here. GL color. Should that be inside here maybe? I'm going to draw white lines first. Notice that I'm using the same GL vertex commands I used before. Now I use 2f instead of 3f, which means I will provide 2 arguments to this one instead of 3, because we're using just x and y and not z. And we're going to draw from -1, 0, 0 to +1, 0, 0. And I could continue with the next line because I want to cross here, but I'm going to just duplicate this. And draw on the other axis. And we'll see what's happening. And that wasn't what I wanted. I wanted a cross, just going across. Let's draw that. I just wanted a cross sections. I could have my 3D view up in this corner, and I have the orthogonal graphic views in these other corners. But we got something totally different. The lines are spinning with the cube. And that's cause, well, let's move that over there. That's cause we have an object, our cube. Just check my other screen so I don't draw over my face. And that cube has a coordinate system that we define the cube in. But we have also rotated it. And we just didn't rotate just the cube. We didn't just rotate this cube. We rotated the coordinate system. And that's why these lines are not vertical and horizontal in the window. They're following the cube. They're sticking out from the cube right now. So they are really pointing to the coordinate system. If I just made one more line, I could show all of the coordinate system. And this is the local coordinate system, or local for the object. So the object's coordinate system. Then we have something called the world coordinate system also. And so far that world coordinate system hopefully has not rotated, but it has, but anyhow. So let's delete all of that, and let's get rid of that. This cross follows the object here. And we're going to do that by doing a GL load identity. And in the other videos, I said that GL load identity is basically a 1 matrix to represent just the 1 in matrix form. Should probably type this in code editor instead, because it would look nicer than trying to do a matrix. Let's see if I can move this along. There we go. So if you have, I was going to say vertex, but that's not the word I'm looking for. I lost the word. Anyhow, doesn't really matter, because it is a vertex in 3D. Vector, it's called a vector. So we have a vector that consists of x, y, and z. That's a vertex in 3D. We can multiply it with a matrix, and in this case we have 1, 1, 1, 1 in the matrix. We just get get x, y, and z back, but normally you write them in the other direction after the matrix multiplication. But this matrix here, that one contains rotation. Checks I don't overdraw my face again. Translation, that's the R. Translation and scaling. So just by taking your coordinates, multiplying them with the matrix, you can get out a scaled translated, which means it just moved from one position to another. So you move it from one position to another. You can rotate it around some axis, and I don't know how to draw scaling, but and you can scale the vertex, whatever I called it before. You can scale it. You don't need to know exactly how matrix math works, not how you do the multiplication or even what all the stuff in the matrix are. It is, I was gonna say fun. It's not fun, it's useful to learn. I wouldn't say it's fun to learn. Anyhow, could be fun if you like math, I guess. Anyhow, let's get this box rotating again in there. It was rotating, let's get it rotating again. So loading identity, so we're saying that the matrix that we're going to apply rotations for this cube is a unit matrix, identity matrix. It contains all ones in the diagonal. That's what that one does, and it stops the rotation. So float rotation and then we need to move this rotation after the load identity. Oh yeah, and since OpenGL is a state system, it contains, let's start this again. It contains a state, and each time we're drawing the function, it's going to update the state. So that's why it was continuously spinning before, because this one was running all the time and updating the state, turning it a little bit more, turning a little bit more, but now we'll be resetting the state all the time here. So we just turn 2 degrees, and that's why you see the green and the blue corners there. So we need to provide an increasing rotation to get the thing to rotate. And now I have everything rotating. What's the cube this is going to have to rotate? Easiest thing here is of course to move this down to after these lines. And there we go. So these lines are in the object coordinate system. Also called the model view. So we can change which coordinate system we are using. We can have model view, or we can have projection. And there is one more that I'm going to call viewport. Just type in that we have a viewport there. So what's a projection? We have two different kind of projections. We have one, we have our object here. We have one with the field of view. So what's this? Is this 80 field of view, I think? No, it's less. It doesn't matter. It's a field of view. And that's what we normally call a 3D. We see it as a 3D. Then we have the no, I can't even say that word. Orthographical. We have the orthographical projection that does not have a field of view, and that just goes directly from this is a screen here, and in this this drawing we would have the screen there. So this is more like the rays from the sun. If you know that they are all parallel, they do not have a field of view. So they are just all parallel, and that's what the ORF system has. So we have a projection matrix that decides which of those two we're going to use and how they are going to be used. And we're going to set the matrix mode to that one first, and we're going to load identities. We're going to nuke it out. Wherever in there, we're going to nuke it out. Then we're going to load the model views as the object coordinate system, and we're going to nuke that out also, just to be safe. We'll start with nuking both of those. Then we're going to draw our lines. And after we drawn our lines, start to nuke out the model view again, because now we're going to draw the object, just to make sure that nothing funny is going on in between there. So now we are back with our cube spinning. And now we're going to talk about the third matrix, how we can modify this object, and the viewport. And let me type this first, and I'll tell you what it is later. So the viewport probably should have like a matrix mode viewport. It doesn't exist that I know of. So if you load identity, it will work on the latest matrix you set. Load identity will work on the latest, but viewport always work on viewport and nothing else. So you don't need to set anything before that. And viewport tells OpenGL, using a matrix, where in the window it should draw something. So right now I restricted the drawing to half of the window. A little bit less than half for some reason, but let's say half. And we need 4 of those, so we need to be able to draw objects in 4 places. This cross should also move now. It shouldn't have moved, so I need to fix that. So of course this first viewport, when drawing the cross, should be the full window. So we have the full window, we have the projection that we initialize to all ones on the diagonal. We have the model view that we do the same with. We draw all of that, and then we can actually just redo this down here. And now divide by 2. And now we got something. Now we cube spinning in one of these 4 windows. Let's have a cube in the other 4 windows. So we gonna just copy and paste this. Should probably make a method of it, but I won't. So let's populate those other squares with a cube. So, something is missing. We're missing this one. So I go to width. I'm confused. I'm confused. Which one am I missing? Height only, right? Can I go? So now we have 4 cubes spinning in different viewports, and they are spinning in their object coordinate system. They're spinning in the model view matrix. So they have own coordinate system per cube. They are rotating their own coordinate system. There's a matrix that transforms that until the world coordinates. We have another matrix that transforms it to the X and Y in the window, the view space, viewport. So we have a lot of things going on here. We have the object hanging around in its own coordinate system. The object doesn't know anything about it. We have the model view matrix that has the translation and rotation coded in. If we multiply these two together, we get the coordinate in world coordinates, and then we multiply that with our viewport. That's a view. Yeah. Then we multiply that with our viewport, and then we get an X, Y in our window, more or less. To be honest, there actually is a matrix here also. the world matrix, the projection matrix, projection view. So let's delete that, delete all of that. And now we're going to make them stop rotating. That's offensive, but all except one will rotate. Let's see which one should be continue rotating. Because we're trying to make something, I closed it, like the old CAD systems, the multiview. And here we got the multiview. One is rotating, two other one is static, but they're showing the same side. We should show different sides here. We need to rotate them, but without them keeping rotating, just rotating once. So we pick the first one, this one, and we're going to rotate them in the projection view, not in the model view. So we're not going to touch how the object is rendered. That's hard, rotate. We're going to rotate it 90 degrees, and we need to pick an axis to rotate it again. So we're going to rotate it on the x-axis, around the x-axis. And we rotated one of them. Let's rotate in one of the others. And now rotate around another axis. There we go. Now we have rotated so we can see all sides of it, and we can also see it spinning in the 3D view. Now I'm going to do something sneaky. I'm going to add in keys so I can move the object around, because that will tell us a lot about the projection view and the matrix view and the viewport. Tell us what's going on. So let's add in that. We're adding a keyboard function, a callback. And then we switch on the key that's coming in, and we have 4 cases. got WSAD, and that's up and down, and left and right. And then we need to add in that to the cube so it actually moves around. And this time I'm going to move the actual cube. There we go. And let's see if this works. So I can move the cube, I can move it to the left. It's just snapped back for some reason. Press D, it snaps back. I guess I have an equal signs on D. Yeah, I do. Probably should have a plus there. Let's rerun it. It happens. So I can move to the left, and you see that two of them are moving to the left and right when I press right. Why? Because one view is from one of the sides and one is from above. Which one I don't know yet. But it will look like I'm moving them in the same direction in two of those views when I'm moving in left and right. Move it up and down. Then there's the two others, and one other is static. The one that is static is the one that's moving away from us. Or towards us. Now that one. That one is moving away from us or towards us. That makes sense, I hope. You can see on the 3D view here, if I just move them kind of a lot, you see how it changes, how it rotates. And that's because it now has a translation around the center, where it's rotating around. So it got moved away from it and now rotating around that point instead. Can also see that it starts clipping. Let's see if I can find it. There we go. It starts clipping. Clipping meaning that it doesn't draw. It's like it's poking out of the screen and it doesn't draw there. Can we get this stop? Let's see if we can get this stop. There we go. As you see the hole in the cube, we're actually looking inside the cube here. Because what should be drawn should be outside of the screen towards me there. And OpenGL won't render that. So we have to move the cube away from us to fix that. But before that, we will talk about frustum. So we have field of view, or we want the field of view. FOV. And either you can have that in some degrees, 80s, or you can have them specified as a distance. So if you have this plane here, that plane, that's our screen now, that distance and that size here, those two together, and we get the field of view. It's something tangents 1/2 of this distance, and something you can figure that out. And OpenGL also want another plane, not our screen. So the screen is the near plane, and I have something called the far plane, that's far away. And the distance between these is used for the depth buffer to determine if objects overlap or not, if they should be drawn. So if I draw something here, object, can I fill it in? I have no idea how to fill in this tool. I have an object there. and draw a smaller object behind it later, there is no need to draw that because that's obscured by the bigger one. Can't see it. And OpenGL can keep track of that with a so-called Z buffer. So we're going to add in one of these field of views. And we're going to add in just one of the cubes. And that goes on the projection. It's called a frustum. And it goes from left to right, -1 to 1. -1 to 1 is top down. And then we have the near plane and the far plane. And they are 1 and 4 away. So we have our field of view. We have our display screen, the near plane. We have the far plane. And this distance here is 1. And this distance here is 3. It's 4 from that point. Look around the camera there. So that's the 1 and 4 specified, and our object needs to be in the middle of it. Else it's not viewable. So if we run this, probably wouldn't see the cube at all. And the cube here has disappeared. It's not within the viewable near and far plane, and it's called clipping. It's clipped away. So we're going to move the object. Or we're not going to move the object. Let's see if we should move before rotate or not. We're going to move the projection of the object. So we're not going to modify the object in the object's coordinate system. We're going to modify how we see it in the projection's coordinate system, in the world view's coordinate system. I'm a bit tired and losing a bit of the terminology here. Sorry for that, but I wanted to make the video. I wanted to get out with it. So sorry for that. Anyhow, we want to move it, and we want to move it backwards. So we want to move it on the Z axis. There we go. So if we wanted to move the object, go down here and say we want to move the object, and we remove that up there. Then we need to push the object farther into the screen by 1, because now it's hanging around 0, 0. It needs to hang around 1 to 4. So we would push it +1 away from us. But since we're working in the projection, you could call that the camera. We need to pull the camera back. We're going to pull it back 1 and see if that's enough to get this object in view. And it is. So we got it in view. But it looks different than the others. Looks really different than the others. It behaves different also. Why is that? Why is that? Behaves really different. First of all, now we are clipping the outer face of it, and we're looking into the cube. So here we got the full cube, and here we got the full cube. Now it clipped away with one face. Continue clipping, 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 clipping. And now we just see the back face of it. And now it's actually drawing so close to me, closer than the near plane, I can't see it. It's not in the viewable distance. So that's one thing that's going on. Now you can also see the size of it. Just move it away from it. And let's see where I can see it. I can see it in both. Okay. So here I can see the side of it. I don't see the side of the other ones. Go over to the other corner. I see the other side of it. I don't see it on the red one here, on the other view. I don't see that side of it. that's display. And that's because this is using the frustum with a field of view, and this is using the orthographical, there we go, orthographical display with the rays that are directly parallel. They are not in field of view, they're going to go out like that, they go like that. So we need to reset this back to orthographical view, but we're going to use this frustum for the 3D cube, and that, let's see which one of that, that's that one I think. I think that was the last one. I mean, it could just delete this because you did see that they was the default, but we're going to use the ortho here instead. Maybe that's a little bit more correct. I will actually put in a rotation here, even though it's not needed. Just to point out that there's no rotation on this one, which doesn't matter which axis we're rotating around. Yeah, that wasn't really what I wanted, but it's interesting effect anyhow. So why is it doing that? Why is it doing that? It looks like a fourth dimensional cube. If you're looking really close at it, it's just rotating. There's a face going up here. But we're clipping in the near plane again. So we need to push this object further back than these other three. Why? Because this is rotating and the outer points of the objects are further away than just the face would be. So when it's rotating, going to clip the plane easier. So let's close down the drawing tool. I'm just gonna push them in 2 instead of 1. Become a bit farther away from the camera. And there we go. You noticed here maybe that on this one, and this one, we can't see a difference. That's also because there is no 3D view on this. They just parallel view. So it doesn't matter if you push them in 100, it will still look the same. The 3D view will get smaller and smaller and smaller. To make it look a little bit more like a CAD system from the 1990s, because that's the look I'm going after. I'm going to paste in something here I just stole from a documentation page because I couldn't remember. It's called GL polygon mode, GL front and back, GL line. So we're going to draw lines instead of polygons. So here we go. We did draw lines instead, and everything works the same. It's just lines instead. But I know that we have an error, got this error, so got to fix that. And then we have the glut reshape function. Void reshape func int width, int height. And we have a global width and global height. And now we can resize our window also. So let's go through this once more. We have a viewport that selects where to draw in the window. We have a projection. That's kind of world coordinates, the camera movement you can put underneath there. The projection here is a matrix. What you modify there kind of can see like a camera. We just set that to the identity matrix, just the one matrix. Then we go into model view matrix, which contains the rotation and translations for the object. And the object is an object coordinate system. And we set that to the identity also. And we draw the lines. And after that, we set a new viewport so you can draw multiple things. Realize you can draw 3D, so you are looking at you're looking at the same object, but from a little different angle, like your eyes. So if you like cross your eyes or more correctly, bend them out, you can see a 3D object in the middle and two faded objects on the sides. If you have seen those images, that's how you do them. Not that hard, right? And then you have the projection, you nuke that one, you set if you want to thrust them with a field of view or not. We do not want it there. We do translate our camera, so to speak. We rotate our camera. Notice that translating something and rotating it is different from rotating it and then translating it. So we're just going to end with doing one thing. Now, we're drawing an object. I didn't say cube. We're just going to delete all of this. Well, let's comment it out if we need it. I'm going to add in glute solid teapot, because who do not want a teapot, right? I mean, everyone wants to draw a teapot. So now we have our let's call it CAD system for an object. We haven't loaded anyone, but the GLUT library contains the default teapot that you can use. So that's the teapot. I feel that this hasn't been the best video to explaining the matrices. I hope it helped somewhat to explain it. So good luck.